Hey everyone! Today we are going to further explore congruent triangles using the angle-side-angle postulate and the angle-angle-side theorem. Let's get started. Let's review the concept of included side. An included side is a side that is between two angles. Let's look at this picture to help us better understand. Now here we have segment AC. It's said that segment AC is the included angle, or the included side, of angle A and angle C. Likewise, segment BC is the included side of angle B and angle C because it is between angle B and angle C. Segment AB is the included side of angle A and angle B, again because it is between angle A and angle B. Let's put this to use. We'll put this to use in the angle side angle postulate. So, our angle-side angle postulate states, if two angles and the included side of one triangle are congruent to the corresponding angles and included side of another triangle, then the triangles are congruent. So, let's look at our picture. We have triangle ABC and triangle RST. Notice that we have two angles, A and R congruent to each other, and angle C and angle T congruent to each other. The included side is congruent to each other in both of them. One thing we can do is mark our picture so that we can clearly see that from one corresponding part to the next, we have an angle, then a side, then an angle. That way we'll know which reason we're using to justify that the two triangles are congruent to each other. Now, in a math statement, we can re-say what this model represents. If angle A is congruent to angle R, segment AC congruent to segment RT, and angle C congruent to angle T, then triangle ABC is congruent to triangle RST. Let's reinforce the concept of that postulate in this example. In triangle PQR and triangle KJL, angle R is congruent to angle K. Segment RQ is congruent to segment KL, and angle Q is congruent to angle L. Now, let's write a congruence statement for the two triangles. One approach is to draw a diagram. So I'm going to draw two generic triangles. I'm going to write the first triangle in any order that I choose, but I'm going to indicate the corresponding parts as congruent to each other in the correct corresponding order, meaning I have that angle R is congruent to angle K. Well, since I've placed R right here, I'm going to indicate that angle K is here, in addition to marking with the correct amount of arcs. And then it states that segment RQ is congruent to segment KL. Well, since RQ is on this side of the triangle, I'm going to say that KL is on this side of the triangle. So I'm going to mark this as L. And to finish this off, it's given that angle Q is congruent to angle L. So I will mark those two angles with the same amount of arcs, in addition to the segments that were already mentioned. Now I have a picture representing that this first triangle is congruent to this second triangle. So I want to finish off my second triangle name. Since it is triangle KJL, and I haven't listed J yet, I will place J right here. So there's angle J. Now, I'm going to state the first triangle, triangle PQR, and that's congruent to triangle, again, the correct corresponding order. P corresponds to J. We'll mention J first. Then we have angle R. Let's name K next. Then we have Q. Let's name L next, since it's in that correct corresponding order. And why are these two triangles congruent to each other? By the angle, side, angle postulate. And again, we know this because the side angle and then the side are touching each other, and the sides are included in the two angles. Now let's consider the definition of non-included sides. Now, here we have segment CA and segment CB. They're considered to be non-included sides of angle A and angle B. And one way to understand this is to state that non-included sides are the sides that are opposite to the two angles. We'll be using this in our next definition. Here, we're going to look at the angle side theorem. Again, since the A and then the A come first, this is how we name it. Angle, side, angle. Now, let's read what this theorem states. If two angles and a non-included side of one triangle are congruent to the corresponding two angles and non-included side of another triangle, then the triangles are congruent. So let's look at the diagram here. I have that triangle ABC is congruent to triangle RST by the reasoning of the angle side theorem. Notice that this side, BC, is opposite angle A, therefore it's a non-included side of angles A and angle C. Likewise, notice that segment ST that's indicated as congruent to segment BC is opposite angle R. Therefore, we say that segment ST is the non-included segment to angles R and angle T. And we have our math statement here indicating so. Now, let's just reinforce this idea of an angle side. Notice that the first part that's mentioned as congruent is an angle, then another angle, then a side. We've got an angle, then a side. This is why we will say the angle side postulate versus the angle side angle postulate. Let's reinforce this concept with this example. Here we have triangle ABC and triangle EDF. Each have one pair of sides and one pair of angles marked to show congruence. So we've got BA congruent to segment FE and angle A congruent to angle E. Therefore, what other pair of angles need to be marked so the two triangles are congruent by angle side? Again, I can mark up my diagram this way so I can clearly see that what I need to have is an angle to force this side to not be included between the two. Therefore, I'm going to want angle C congruent to angle D. Again, this is because of the angle side postulate. Angle side postulate. Therefore, if angle C was congruent to angle D, these two triangles would be congruent by the angle-angle side postulate. Now let's tie together all of our concepts. Let's determine whether each pair of triangles is congruent by the side, 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 or the side, angle, side, or the angle, side, angle, or the angle, angle, side. If it is not possible to prove that they are congruent, write not possible. So let's look at the first pair of triangles that we have. I have two angles and a non-included side, and two angles and a non-included side. So I can mark up my triangles to make it very clear the parts that are given. Notice that this side is not touching or between these two angles, therefore it's non-included side. Same thing with this first triangle. Therefore, we're going to say that the two triangles are congruent by the angle-angle side postulate. Now let's look at the next diagram. Here I'm given a side congruent to this side, a side congruent to this side, and then an angle congruent to this angle. We do not have an included angle. Therefore, this is not enough information to justify that these two triangles are congruent. We could if it were the side angle side postulate, but we don't have a postulate or a theorem that spells a bad word. Therefore, we're going to say not possible. And this concludes our introduction to congruent triangles using the angle side angle postulate and the angle angle side theorem.
Made with Doodlecast Pro.